Hello everyone, this is Eddie Britt, and I am going to work through a midterm review for you to get you ready for your midterm. Your proctored midterm will be very similar to this. It's going to be 20 questions. They'll be in a different order, but I've now assigned this thing called midterm review. It's this exact same test. I locked all the questions, so you will not get any other types to practice, but if you watch this video and you work through it at least once, you should be good for your final exam. Have it set to you where you can take it as many times as you want. Alright, well, let's go ahead and get started then. Let's look here at question number 1. Consider the following table representing the distribution of the cost of a paperback book in dollars. Determine the cumulative frequency for the second class. Alright, so this is the first class here, the second class, the third class, so on and so forth. And so if I want the cumulative frequency for the second class, a cumulative frequency table, what would happen is at each new class you simply add up what you had previously. So the second class, its cumulative frequency will be 19, 14 plus 5. Alright, so I have 19 in here. Now let's look at step 2. Same table, determine the cumulative frequency for the fourth class. Alright, so to get the one here, you need to start at the top. We have 14 plus 5. I guess I could use a calculator here. Let's see. 14 plus 5 plus 8 plus 9. Alright, it's the fourth class. Fourth class, so 14 plus 5 plus 8 plus 9. So if this was a cumulative frequency distribution table drawn, there would be a 36 right there. Okay. Let's look at the next problem. Question number 2. Determine whether the statement describes a population or a sample. The final exam score of 6 out of 38 students in your economics class. Okay, so 38, if you were talking about the 38 students, that would be the population. But if you're taking just 6 out of that 38, then that's a sample. Okay, a sample. Question number 3. We're going to use this histogram. It shows exam scores for pre-algebra class. Use the histogram to answer the questions. Alright. So this would be the first class, second class, the third class, the fourth class, the fifth class, and the sixth class. We want to find the number of the class containing the largest number of exam scores. So here's our frequency here, and I actually wrote the frequency above, so it makes it really easy to read. You don't even have to guess anything. So you see that the tallest one will be the class that has the largest number of exams. And the way that you would list these, if this was a table, you know, you start with the smallest. So this is the first class, second class, third class, fourth class, fifth class, sixth class. So class number 5, that's the one that has the largest number. Alright, step 2 says to find the upper class limit of the second class. Alright, so the upper class limit of the second class. That's going to be, alright, so these numbers here, the 0.5, and more than likely you can't make a 0.5 on the test. The way that histograms are, these numbers here, the numbers, these are class boundaries is what they're called. And so these are the numbers between each class. So the actual classes are a little different, but so if I was to look here, this is the first class, this is the second class. The upper class limit is going to be 80. Okay, it's going to be the number 80 because that would be the largest number in the second class. And then you have 80.5, and then you know, the way that these classes will be is like 70. This would be 71 to 75, I believe, and then this would be 76 to 80, and this would be 81 to 85, and so on and so forth. Okay, so the upper class limit of the second class would then be 80. Find the class width for the histogram. The easiest way to find the class width, you can just you can take any two consecutive class boundaries on the histogram and just subtract the smaller from the larger. So if I said 75.5 minus 70.5 or 80.5 minus 75.5, you should get the same answer for all of those. So you can pick any two continuous. I'll just pick the first two, and I'll say 75.5 minus 70.5, and here's the class width, 5. Alright. And there may be more than one way for you to get that. That's just one way that you could do it if you have a histogram. Find the number of students that took this exam. Alright, so that's going to be pretty easy to do, right? Because all we need to do is just add up all of these exams. I mean, how many were in each class? So, of course, you can do it in your head, that's fine, but I suggest doing it with a calculator. Maybe even a handheld calculator, so that you may not make a mistake like I do from time to time, clicking right along. So, let's see. Oops, see, I gotta go back. Make sure I put in all the right numbers. So we have 17 plus 16 plus 12 plus 11. See, I made a mistake right there. It's supposed to be plus 18 plus 10. So I'm going to add 2 more to that. And that's it, 84. So I did type in the wrong number, but I adjusted for it at the end. So the answer, I believe, is 84. I'm not really going by any key or anything, so we'll see how I did at the end. Alright, and number 5. Find the percentage of students that scored higher than 90.5 percentage. So we need to make sure we make it as a percent. It says then round your answer to the nearest percent. Okay. So here's 90.5 right here. We want to know what percentage these two would make up of the entire group. So it's just part over total. So 18 plus 10, that's 28. So we have 28 divided by, we had 84. So that fraction will simplify, but I don't have to do that because I want to change it into a percentage anyway. So 28 divided by 84. Alright, it's 0.3 repeating. So it's 0.3, 3, 3, so on and so forth, forever repeating. So if I want to change that to a percentage, move the decimal 2 places over to the right. So that's 33.3. It's 33 1/3%, but it says to round to the nearest percent. So since this is less than 5, I'll just keep that as 33. So my rounded answer is 33%. So that's what I'm going to put in the test. That finished up question number 3. Now question number 4. Classify the data, indicate whether the data is qualitative, quantitative, indicate whether the data is discrete, continuous, or neither, and indicate the level of measurement for the data. The number of deaths, each one of 25 different diseases caused last year. Alright, so the number of deaths. So I'm sure it'd be like, different types of diseases. So think of some types of diseases and the number of deaths that each one of them caused last year. So that's definitely quantitative, some type of quantity. Then is this data discrete or continuous or neither? It's countable, so it's discrete. And then what is the highest level of measurement the data possesses? So these levels that are listed here are from, I guess you could say, simplest to most complex in a way. Remember, nominal are just like types. So maybe colors or maybe male and female, or just something, independent, Republican, Democrat. So, I mean, there are things that maybe you could sort, but you can't add or subtract, divide, anything like that. So it's definitely not nominal. Ordinal, maybe they can be ordered somehow from like least to greatest or something like that. But they would not be ordinal, because they probably wouldn't be ordered, unless it was maybe by number, least to greatest, or by alphabetical or something, but that really wouldn't have anything to do with the set of data. So it is a little more complex than that. The next is interval. An interval would be, well, hey, can I add, can I subtract? But there is no natural zero starting point. So like for interval, that is. This does have a natural zero starting point. If a disease has 0 deaths, then it can't have -1 deaths. Like with temperature, you can have negative values, so it's interval. So that leads us on to ratio. Has all of those categories, plus you can add, subtract, multiply, divide, find meaningful ratios, and there is a natural zero starting point of 0, okay, because that would be no deaths. So I'm going to say that's ratio. We'll see, but pretty complicated. Alright, consider the following data. Here's our data here. We have 1, 2, 3, 4, 5, 6 data items. Determine the mean of the given data. So the mean, if we add all of these together, so -13 plus 0 plus 13 plus 6 plus -14 plus 8, we get 0. Okay? So 0 divided by 6 is 0. So the mean is 0. The median. To get the median, we need to order these numbers from least to greatest. Remember, with negative numbers, the larger the number is, it's actually further to the left. So -14, -13, 0, 6, 8, 13. Alright. Sorry. So now to find the median, that is the number directly in the middle. If you have a negative or an even number of values, there's not going to be exactly a middle number. So what you have to do is take the two middle numbers and find the mean of those. So 0 plus 6 divided by 2. 6 divided by 2 is 3. Okay. Now determine if the set is unimodal, bimodal, multimodal, or has no mode. Like a unicycle has one tire, so would unimodal have one number. Bimodal means that it would be 2, multimodal, more than 2 that are repeated. No mode, that means that no number would be repeated. So it doesn't look like anything's repeated here, so it has no mode. Right? Number 6. Consider the following frequency table representing the test scores on a test. Determine the lower class boundary for the fourth class. Alright, so 1, 2, 3, here's my fourth class. The smallest number, the lower class boundary, is 59. Alright, so let's see. That's actually the lower class limit is 59. Ooh, almost missed that one. So you have to be careful about this wording here. Lower class boundary. So how do we get the boundaries? The boundaries are actually the numbers halfway between any consecutive upper and lower class limit. And so the way you get that is you see that what the gap is between any upper and next lower class limit. You can see that's 1 unit. And so if we take that gap of 1 unit, you have 1 unit between any upper and lower class limit. Divide that by 2, so that's 0.5. So that's how many units you want to go between the two to get directly in the middle. So like that 0.5, you go 0.5 more than this, and that's the number between 32 and 33. So 32.5, 45.5, 58.5. So you have to, if you want to know the boundary, the lower class boundary of the fourth class, 1, 2, 3, 4, you come to this lower class limit and then go 0.5 less than that. That would be 58.5. Again, how did I get that magical number? Class boundaries are a little confusing. Alright, the way you get a class boundary, different than a class limit. You take how many units are between any consecutive upper class limit and lower class boundary. On this particular frequency table, that would be 1 unit of whatever, one point. Alright, divide that by 2, you get 0.5. So if you go 0.5 more than this, or 0.5 less than this, you have the class boundaries. Okay? And so the lower class boundary for the fourth class, 1, 2, 3, 4, the lower class boundary, if you subtract 0.5 from 59, you get 58.5. Alright, so you need to make sure that you pay attention whether it says class limit or class boundary. Alright, determine the upper class boundary for the second class. Alright, so the second class is here. Here's the upper class limit. We said we were going to add 0.5. This is the same table. Or subtract 0.5, depending on what term we're at. And so since I'm at this number, the upper, if I want the upper class boundary, you add 0.5. So 45.5 will be the upper class boundary. Alright. Determine the class width of each class. Alright, so the class width. If we take any two, there's a couple of ways to do this. Since we have our tables listed like this in a frequency distribution, you can take any consecutive two lower limits or any two consecutive upper limits and find the difference. So if I said 33 minus 20, that would give me 13. If I said 45 minus 32, that would give me, I said 15, I meant 13, sorry. 33 minus 20 is 13. 45 minus 32 is 13. So that is the class width. It's 13. So the difference between any two consecutive class limit, or it could be any two consecutive class boundary, but we have the limits listed there. So that's the easiest thing to find. Step 4. Choose the interval that contains the score 69.3. 69.3 is between 59 and 71. So, right there. Didn't require much explaining. Determine the number of scores between 19.5 and 58.5. So 19.5 is the lower class boundary for the first class. 58.5, you can either think of it as the upper class boundary for the third or the lower class boundary for the fourth. Okay? So if we add 14, 2, and 15 together, because you know, I could go to 58.5 as the lower class boundary, but it wouldn't include this class. Okay? We want the scores between 19.5 and 58.5. So it's going to be this class, and this class. Add those together, looks like you get 29 and 31. Okay? That finished question number 6. Alright, question number 7. Suppose that quiz scores in a beginning statistics class have a mean of 7.0 with a standard deviation of 0.6. Using Chevy's theorem, and I believe I mispronounced that, Chev's theorem, state the range in which at least 75% of the data will reside. Please do not round your answers. So that please means don't. Alright, so we've got to know what that theorem states. So in your ebook, if you look on page 150, you'll see Chev's theorem, and at first it seems a little confusing, but it's really not too bad. Okay, if we want to know these values that lie within 75%, actually, one of the examples that it gives for the theorem is when k equals 2. That's 2 standard deviations from the mean. And then it gives one for k equals 3. And that 75% relates to when k equals 2. That is... that tells you that for 75% of the time, or 75% of the data, will lie within 2 standard deviations of the mean, or the the mean. I don't want to say the average. That's a bad word. All right, so we have the mean of 7.0. We have a standard deviation of 0.6. So within 2 standard deviations of the mean, I'm going to have at least 75% of the data, according to this theorem. So the easiest way for me to do this, you have, let me write this down again, you have a mean of 7.0, and you have a standard deviation. These are population variables, and maybe they're sample variables. It really doesn't matter for one of these. Let's say that's 0.6. And so the key to this is the at least 75%. If this was different, if this was another popular percentage is 88.9%, then we would calculate it slightly different. We'd use 3 standard deviations. And so we have the mean here at 7.0, and if we go 2 standard deviations above the mean, so 0.6 and 0.6, you just want to simply add 0.6 to that twice, then that's going to give you that upper range number. So 7.0 plus 0.6 plus 0.6. So the larger number of your range is going to be 8.2. That's 8.2. And then it's 2 standard deviations of the mean. And what that means is either above or below. So the way we get the other number is by going 0.6 and 0.6 again in the other direction. So 7.0 minus 0.6 minus 0.6. So that's 5.8. So the lower boundary here is 5.8. And how I've seen this written before, and it's written like this in your book, is you say the mean plus or minus 2 standard deviations. And so if you were just to plug in 7.0 and 0.6, multiply that, and then say plus or minus, you get the same answer. I just wanted to illustrate that's exactly, 2 standard deviations means you're just moving away to the left of the mean, or I guess you could say before the mean, by 0.6 and then 0.6 more. Anyway, you get 5.8 for that one. So 5.8 to 8.2. That's our answers. Okay. The Pizza Pie and Go sells about 1,330 one-topping pizzas each month. The circle graph displays the most requested one-topping pizzas by percentage for 1 month. Alright, looks like I need to scroll down here. Find the number of sausage pizzas sold each month. Round your answer to the nearest integer. Okay. So look for the piece of the pie chart for sausage. Alright, so here's the sausage right here. We were told that they sell 1,330 one-topping pizzas. You've got to be lying to me, because I don't see a pepperoni here. So this place is weird. This must be a strange place. Alright, anyway, and I don't see just a cheese pizza. I guess it's not a topping, unless, I don't know, it kind of is. We want to know what is 23% of 1,330. So, I mean, to write that out, you'd say, this is question 8 for me, 1,330, and then it was 23%. So times 0.23. I'm not going to do that out by hand. I'm a mathematician and I'm lazy, so I'm going to use a calculator whenever I can. I know how to do it by hand, so it's okay to use a calculator. Alright, and then it says we want to round to the nearest integer. We have 305.9. Of course, that'll round up to 306. Find the number of ground beef pizzas sold each month. So look at your percentage for ground beef, and we're going to do the same thing. It's still 1,330 pizzas. Ground beef 17%, so just say 1,330 times 0.17. Alright, round out to the nearest integer, and that'll be 226. Alright, anchovy pizzas. It's the same percentage as ground beef, so we don't have to work the problem again. They were both 17%, so it's going to be the same answer. So less work, that's good. Alright, find the number of ham pizzas. 24%, so that's 0.24. We'll do the same thing. We'll say 1,330 times 0.24. Round that to the nearest whole number, that's 319. Okay. And the number of pineapple pizzas. It's 19%. So 1,330 times 0.19. Around that, that's 253. Right. Alright, so that one, by far the easiest, probably the easiest problem so far. Alright, so this says, the following bar graph represents the number of dogs and cats treated by a local vet during 1 week. You know, this graph can be a little confusing because it has two values, like one on top of the other. I'm just assuming that they treat a lot more cats, it looks like, since the cats is always on top of the dogs there. That's just what it looks like. I haven't really analyzed this graph much. But it says, were there more dogs or cats treated during the week? We see a side-by-side bar graph. That might be a good idea. See how they were on top of each other. See, that's a little confusing there. I would think, and I was, I thought wrong, because by this being on top, it makes it almost look like there were 8 here. There were 8 total, okay? And so, yeah, that's not the case. I would definitely look at the side-by-side bar graph, because one on top of the other, man, that's just too confusing. This makes a lot more sense. So were more dogs or cats treated during the week? If I wanted to just do a guesstimate, it looks like 4 out of the 5 days there were more cats treated, and by a lot. So my guesstimation would be that there were more cats treated. But let's not do that. Let's be exact. So let's add up the number of dogs and let's add up the number of cats. Okay. So if I wanted to add up the number of dogs, looks like it's going to be maybe 2 plus 1 plus 2 plus 1 plus 3. So that's going to be 9. So yeah, so we got 9 dogs that were treated. Cats, it's going to be 6 plus 4 is 10. Well, we have more right there. We have a winner, but let's keep going. plus 5 is 15, plus 5 is 20, plus 1 is 21. So way more cats than dogs. Let's look at part 2. On which day was the greatest number of cats and dogs treated? Well, I guess this would be a time when having these graphs on top of each other would be useful, because this is both the cats and dogs, and so it looks like Monday is the winner. If you were looking at the side by side, you need to add like 2 and 6 together and get 8, and that would be the largest of any of these if you added the 2 together. So Monday is the winner. Okay. A sample of 105 registered voters in a state in which the party's candidate in a state where asked which party's candidate they plan to vote for in the upcoming election. Now, that was very confusing. It didn't sound like I read that at all. Let's see. A sample of 105 registered voters in a state were asked which party's candidate they plan to vote for in the upcoming election. That makes a little more sense now. 59 of those surveyed said they plan to vote for the Republican candidate. Calculate the sample proportion of voters who plan to vote for the Republican candidate. Use the rounding rule for calculating the proportion. Alright. So, if I'm going to round, it must want a decimal. Okay. And so 59 out of 105. That's our proportion we're looking at. 59 over 105. So we just pop that in the calculator. Alright. Now let's enter in this answer. Oops, I accidentally went back, so maybe I didn't. Maybe I accidentally went forward. Sorry about that. I'm going to get away from this easy problem. Alright, so 59 out of 105. 59 divided by 105. I got 0.562, right? The 3 decimal places. So 0.562. Here's my answer. Okay. Now on to this problem. Oh yeah, we like this. Sample variance. So, those of you, I'm sure that you're happy there was a variance problem here. The variance, the standard deviation, is very important. We're going to use that on down the road. So it's important that you can calculate those. You might want to use a calculator to do that. Anything that I ever want to do on a calculator, believe it or not, I just go to Google and say, how do I blah? So how do I find sample variance on a TI calculator? How do I find sample variance on whatever kind of calculator you have? And more than likely somebody out there has that same question and it's been answered. So I would strongly suggest, you know, just go to your favorite search engine and try that way. If you can't make any sense out of what comes up, I can show you how to do that. I just don't make it a habit of showing shortcuts on every problem. Even though, you know, if it was me and I was working this out, I would know how my calculator worked this out so that I would not miss it on the test. But let me work through this the long way. I guess the same way that is shown in the book, and the same way that a lot of my students will start out learning how to do this. And it's okay to do it this long way, especially at first. And you should have enough time on this test. And this isn't too big of a data set. So let's go through this really quick. Alright. And I'm going to do, there's a couple of ways to find variance. And I'm just going to do this the way that the book does it. So maybe somebody has showed you something different. But the way that I like to do this, you need to find the mean of the set of data. So that means add all these numbers up, see what the mean is. All right, so 10 plus 4 plus negative 7 plus 4 plus 10 plus 4 plus 10. So I got 35, and that is 7 data items, right? 1, 2, 3, 4, 5, 6, 7 data items. So the mean of this set of data is 5. Alright, so if you want to call this a sample, I mean, you can list the mean as mu, or you can list the mean as x bar. I think your book probably would list it as x bar. Alright, so we said that's going to be 5. Okay, so then you take each data item and you subtract the mean. So this is going to be x minus x bar. Alright, so I'm going to list each item: 10, 4, negative 7, 4, 10, 4, 10. And then I'm going to subtract 5 each time. Okay. Let's see what that gives me. So these are the deviations. So that's 5, negative 1, negative 12, negative 1, 5, negative 1, 5. Alright, so now we have these deviations. Now the deviation squared, you need to put in another column. So this would be x minus x bar squared. So you just square each one of these. So that's 25, negative 1 squared is 1, negative 12 squared is 144, negative 1 squared is 1, 25 again, negative 1 is 1, and 25 again. Alright, so to find the variance, the sample variance, so that's s squared is the variable we use for that. You need to add all of these up, all of your squared deviations. Add those up. So let's see. 25 plus 1 plus 144 plus 1 plus 25 plus 1 plus 25. 222. Okay. The way that you find s squared is you take the sum of x minus x bar squared and divide by n minus 1. Now this sum right here, the sum of all the squared deviations, that is sigma x minus x bar squared. That's what that is. That's the sum. So it's 222. Now this n, this is the number of data items. So how many number of data items was in the original set of data? 7. Okay? So that's what that n is equal to. That's going to be 7 minus 1, or 6. So 222 divided by 6. Divided by 6. 37. Alright, we use one more decimal place in the original set of data. The original set of data didn't have any decimal place, so we're going to use one decimal place. So the variance is 37.0, one decimal place. Alright, so that is the sample variance. Yes, if you have a calculator that will do that, you can do that in about 10 seconds, where it took me about 2 minutes. See what step 2 is. Standard deviation. Alright, there's not a lot of calculations for this because I've already found the sample variance. Okay? The sample variance is S squared. The variable that we use for sample standard deviation is S. Well, how would you get S if you had S squared? You take the square root of it, right? The same way that the variable you would get from S squared to S is the same way you go from the variance to the standard deviation. You take the square root of the variance to get the standard deviation. Okay. So let's do that in a calculator. 37 or 37.0, and here's the square root button here in the Windows calculator. And so we want to round that to one place, one more decimal place than the original set of data. Alright, so that's going to be 6.1 is your answer for your sample standard deviation. 6.1. Calculate the range. So the largest value minus the smallest value. It looks like the largest value is 10, the smallest value is -7. So 10 minus -7. That's 17. Okay. 17. Moving right along. Select the graph that best illustrates the following distribution shape. Uniform. Uniform is, its graph is approximately rectangular. So look at those 4 graphs, and which one do you think is approximately rectangular? There's only one that's close. I mean, it's not going to be exact. It's got to be that one, right? I mean, you could make a rectangle right there. So. Alright, let's classify the following data. Indicate whether the data is qualitative, quantitative, discrete, continuous, neither. Indicate the level of measurement for the data. Alright, the IQ scores of students at a local college. So let's think about, what do we think about when we say IQ scores? You know, they're numbers, right? I'm sure that some of you have seen something related to IQ scores, whether you've taken a mock IQ score test or the real thing. I can tell you my IQ is not very high. If I had to estimate it, it's probably about 125. I don't claim to know everything or be super smart. But you know, mine is probably about where you would expect it for a college professor. So that is definitely a quantity, right? The IQ score. It's not like you have a red IQ score or a blue IQ score. It's an actual number you can count, so that's quantitative. Now, would those be continuous? You know, can you have an IQ score of 125.9? No, they're whole numbers. They're countable. Okay, so those are most definitely discrete. And then, let's see, what is the highest level of measurement the data possesses? Alright, so nominal, it's more than just a category. Ordinal, you can order them, and the order has meaning, really, it does. So interval, now this is a close call between interval and ratio. Interval has a ratio has a natural zero starting point. And you may think, well, an IQ score, if it scores from 0 to whatever, but not really. I don't believe anyone could score a 0 on an IQ test score. I guess if you didn't take it, but that doesn't make it, that's not what it's talking about. So that's not really a meaningful 0 starting point. like say, I believe your book, if you're talking about money, like salaries, a natural zero starting point of a salary would be 0, you know, if you were not getting paid. If you're getting paid nothing. So that would make sense for a natural zero starting point. But the actual, an IQ of 0, that's not really a meaningful starting point there. And you can find differences between IQs, and I'm not going to go through the different classifications of people according to their IQs, but you know, no one's going to have a 0. Even people who are mentally handicapped, they have, you know, an IQ score of a certain range. So there would be a good argument here for one of these, but if I had to guess, I would just say interval. And I'm not really guessing, and if I had to make an educated guess, I would say interval. Okay. So, let's see, width doors in a restaurant, or an example, widths of doors in a restaurant are an example of which type of data? Okay, so statistic parameter, no, I believe we don't have a sample, we don't have a population. You go ahead and mark those two out. So either it's quantitative or qualitative. Qualitative is more like labels. So quantitative, yeah, the widths of doors, they can be measured. Quantities, yeah, that's it.